All right, so here we're going to do solutions of polynomials, and this is basically kind of an extension of what you already know about parabolas. All right, so when you have a parabola, a parabola is also a polynomial. Remember, your solutions are your x-intercepts, right? So normally you look for x-intercepts. Now remember, you don't have to have x-intercepts because that means your solutions are imaginary, but this one does. So I can tell that my zeros here are at 2 and 4. So at x equals 2 and 4. So remember, that means my factors are x minus 2 and x minus 4. So this is like a possible equation for my parabola. And frankly, it is the equation for my parabola. If I work that out, I get x squared minus 6x plus 8. Because remember, this makes negative 4x and negative 2x, getting my negative 6. And I can tell this because my parabola is following that pattern of like over 1, up 1, over 2, 4. This is just my basic parabola. There is no leading coefficient other than 1. So there's no stretch or shrink going on right here. Okay, so we don't have to multiply it out. I could have just written this, y equals that. Also, I just decided to multiply it out because it would be kind of easy. All right, so looking over here, you can do the same thing to a polynomial. So let's try to deduce a little bit going on here first. I don't see any weird flat turning areas or anything like that. So nice clean turns here. I have 1, 2, 3 turns. So that means this is probably an x to the 4th. And look at this. I see 1, 2, 3, 4 x-intercepts. So it is most definitely x to the 4th. And, both ends are pointing down, so it's going to have a negative in front of it, reflection. All right, so let's see. My zeros, I got negative 4, I got negative 1, I got 2, and I have this one right here. That's 3.5. So 3.5, but I need that in a different form. 3.5 is 3.5. And remember, I got to change that to an improper fraction. So 3 times 2 is 6. 6 plus 1 is 7 over 2, because I'm going to need that for my factor. So negative 4 turns into x plus 4. Negative 1 is x plus 1. 2 is x minus 2. Now this last one right here, remember, my answer is 7 over 2. So I'm going to recreate the factor that did that. So I meant that 2 would come back over here, so I have 2x equals 7. And 7 comes back over here, so I'd have 2x minus 7. 2x minus 7 would produce this answer when I set it equal to 0. So 2x minus 7. All right, so my possible equation is those 4 things. I don't want to write them all again, but basically those 4 things, I'll just write them again. Let me see, x plus 4, x plus 1, x minus 2, and 2x minus 7. And I know why I wanted to do that. I wanted to point out the fact that I am going to have a negative in front of it, right? And, there might be some kind of like stretch or shrink in there, but for now, based on this, if I put this into Desmos, I would get a graph that at least does this, crosses in these places and points down. Okay, and then I might need to play with some kind of stretch or shrink to make these values appear here. All right, but this is just the basics. All right, so the factored form of a polynomial, if I have these factors here, x minus 5, x plus 2, 3x minus 2, I know, let's see, my zeros are going to be 5, negative 2, and also 2/3. I also know I have x, so that's going to be x to the 3rd. So I'm going to have an x to the 3rd, so I know that the end behavior is going to go like this. The right side is going to go up, the left side is going to go down. And I would also know I'd probably expect at most 2 turns. All right, and that's about it. So I would know basically that it's crossing at 5, negative 2, and then also 2/3. It's coming up here, going down there. All right, and actually I can also tell the y-intercept if I plug in 0. So if I plug 0 in here, I get negative 5. 0 here, I get 2. And 0 here, I get negative 2. So if I multiply that out, let's see, 10 times 2, 20. So I get positive 20. So that's going to be too big for us to graph, but this thing goes way up, crosses over, comes down here, probably looks like that. So that's just like an estimate of what it looks like. Obviously, it's not exact. All right, here, what I know my zeros or x-intercepts are going to be, let's see, negative 3 over 2, positive 1, and negative 3. So this is a double root. So when I graph this, it's going to bounce there. And so let's add up our exponents. I got a power of 1. This one's going to be power 2. So I have x to the first, x squared, and this next one is going to be an x. So altogether, that means I have x to the fourth. So this is an even. So that means both ends go up or both ends go down. Well, I have a negative, so both ends go down. All right, so let's see. Negative 3 halves, that's 1 1/2, 1, and negative 3. I know both ends go down. Okay, I know that 1 is a double root, so that means it's going to bounce off of that, right? So let's see if we can find our y-intercept. So if I plug in 0 here, I get 3, so it'd be a negative with a 3. 0 here, I'd get negative 1 squared. 0 here, I'd get 3. So let's see, that's going to be 3 times 3 is 9, times 1 is 9, and then negative, so negative 9. That's not too low. So it's going to come down and cross here, come up through there, and go back down through there somehow. So it's, ugly picture, but basically, you could draw it a little bit nicer, but, it comes up through there, goes down through negative 9, bounces and comes back down, right? So this is basically what your graph is going to look like. Might look a little different, but the general idea. Yeah, I think we got everything covered. So it's going to have up to 3 turns. Right, we're going to have 4 x-intercepts, but we can see this one's a double, so that's why I only have 3. And that's it. I think that is it.